Do you really think we have uncovered all the secrets of the cosmos, far beyond our own galaxy? A collection of thousands of islands in space known as the Hercules Cluster holds the keys to profound enigmas. This dense swarm of galaxies is not just a pretty picture. It is a cosmic treasure chest overflowing with 25 mind-bending mysteries that defy our current grasp of physics and reality. By the end of this journey, you will discover how this single cluster challenges the very foundations of what we know about the universe. We will uncover a supermassive black hole that breaks all the rules and a vast void where galaxies simply disappear. What does it feel like to confront a mystery that could rewrite the textbooks? Deep within the heart of this galactic swarm, a true leviathan stirs. Hercules is a galaxy anchored by a supermassive black hole, but this is no ordinary cosmic vacuum. It unleashes twin jets of energy so immense they create colossal lobes of radiolight, structures that span an almost incomprehensible 1.5 million light-years across. To grasp that scale, picture a single beam of light, the fastest thing in the universe, taking 1.5 million years just to travel from one end of this structure to the other. These jets are a profound puzzle. According to our best models of how black holes feed, the energy pouring from Hercules simply should not be possible. The standard idea is that a black hole's power comes from its accretion disk, a swirling whirlpool of superheated gas and dust. But the energy output here is like a small campfire producing the heat of 1,000 suns. The accretion disk model completely fails to explain the sheer violence and scale of what we are witnessing. This points to something far stranger at work, a hidden engine or an exotic form of matter we have not yet discovered, fueling an anomaly that defies the very laws we thought governed these cosmic beasts. But the staggering power of Hercules is only the first piece of a much larger puzzle. Surrounding these brilliant galaxies is an invisible architecture, a cosmic scaffold built from the most mysterious substance in the universe, dark matter. We cannot see it, but we can witness its ghostly grip through an effect called gravitational lensing. The immense gravity of these dark matter filaments acts like a giant lens in space, bending and distorting the light from galaxies that lie far behind the cluster. By meticulously mapping these distortions, astronomers have traced out the intricate web of dark matter that holds the entire Hercules cluster together. Yet this revealed map is deeply confusing. The filaments are there, but their arrangement and sheer density are wrong. They do not match what our most sophisticated supercomputer simulations predict. According to the standard model of cosmology, known as the lambda-CDM model, the universe's structure should have evolved in a very specific way after the Big Bang. The dark matter in Hercules, however, appears too clumpy and concentrated in some areas while too sparse in others. It is as if you built a house following the blueprint perfectly, only to find the walls are in the wrong places and the foundation is a completely different shape. This mismatch is not a small error. It is a fundamental crack in our understanding of cosmic evolution. Either our foundational lambda-CDM model is incomplete, missing a key ingredient about how gravity works on the largest scales, or the dark matter itself is not what we think it is. Perhaps it is not a single, simple particle, but a mixture of different types, some of which interact in ways we have never considered. The very skeleton of the cosmos, it seems, is hiding a secret that could force us to redraw our map of reality itself. This invisible skeleton of dark matter holds another secret, a great cosmic emptiness known as the Hercules Void. Nestled within the bustling galactic neighborhood of the cluster is a region of staggering size that is almost completely devoid of galaxies. It is a ghost in the machine of the cosmos, a place where the expected tapestry of stars and galaxies simply fades into an unsettling silence. The density of matter here drops so precipitously that it challenges our understanding of how the universe arranges itself. What could possibly carve out such a perfect and vast sphere of nothingness in a place that should be teeming with cosmic life? One compelling theory suggests this void is a relic from the universe's explosive birth, a colossal bubble formed in the first fractions of a second after the Big Bang. As the infant cosmos expanded at an unimaginable rate, pockets of different energy density could have been frozen into the fabric of space-time. The Hercules void might be one of these ancient, inflated bubbles, a cosmic fossil that has persisted for over 13 billion years. Another, even more mind-bending idea is that this void is not empty at all, but is instead a boundary. Some theoretical physicists propose it could be a bruise on our reality, the site of a cataclysmic collision with another universe in the vast multiverse, an event so profound it swept the area clean of galaxies. Or perhaps the void is a universe in itself, a separate cosmic domain with its own physical laws, nestled seamlessly within our own but forever invisible and untouchable to us. Then there is the most unsettling possibility of all, that the void is the scar of an ancient, universe-altering event that simply erased matter. Could some unknown physical process, a force or particle we have not yet discovered, have effectively cancelled out the existence of everything within that space? We are left staring into this abyss, a silent reminder that our maps of the cosmos are still filled with blank spots that whisper of forces beyond our current comprehension. And if the very structure of space can contain such profound emptiness, what other impossible structures might be hiding in plain sight? Yet even the profound silence of the void is not entirely empty. Drifting through the cluster's crowded core are ghost ships, vast islands of stars known as ultra-diffuse galaxies. These cosmic phantoms are as large as our own Milky Way, yet they contain only about 1% of its stars. They are enormous, wispy clouds of suns, so faint and spread out that they were nearly invisible to us for decades. Their very existence is a paradox. How can something so large and fragile survive in the Hercules Cluster, a violent environment where galaxies constantly collide and tear each other apart with their immense gravity? It is like finding a delicate soap bubble floating, completely intact in the middle of a hurricane. According to everything we know about galaxy formation and the protective cocoons of dark matter that surround them, these ghostly giants should have been shredded to pieces eons ago. The prevailing theory is that a galaxy's dark matter halo acts as a protective shield, its gravity holding the stars together against external forces. But the dark matter halos of these ultra-diffuse galaxies appear to be strangely deficient, or perhaps their dark matter is distributed in an entirely different way, leaving them exposed and vulnerable. This suggests that our understanding of how dark matter clumps around galaxies is fundamentally flawed. Perhaps these galaxies are the ancient, stripped-down skeletons of once normal galaxies, their outer stars and dark matter scoured away by a violent past. Or maybe they were born this way, forming in a quiet, slow-motion process that we have never witnessed, creating fragile giants from the start. Their survival forces us to ask if we have completely misunderstood the relationship between a galaxy and its dark matter anchor. What other ghostly forms are we missing, hiding in the blinding light of their brighter neighbors? These ghostly giants are not the only ancient survivors hiding in the cluster. Scattered among the vibrant spiral galaxies are cosmic fossils known as red nuggets. They are dense, massive cities of old red stars packed into a space far smaller than a galaxy like our Milky Way. If the Milky Way were a sprawling metropolis, a red nugget would be its entire population crammed into a single, dense downtown district. According to our standard models of galaxy evolution, these compact powerhouses should not exist in the present-day universe. They are relics from a much earlier, more violent cosmic era, and they were supposed to have grown over billions of years, merging with other galaxies to become the large, puffed-up, elliptical galaxies we see today. But here in the Hercules Cluster, they remain, seemingly frozen in time. Why did their growth simply stop? What force put their evolution on pause? One possibility is that they exhausted their fuel supply too quickly. After a ferocious burst of early star formation, they may have used up all their available gas, leaving nothing to build new stars or to gravitationally attract smaller neighbors. Another, more dramatic theory involves the environment of the cluster itself. As these galaxies orbit through the dense core of Hercules, they might be moving at such tremendous speeds that any potential merger with a smaller galaxy becomes a high-speed flyby, a gravitational encounter too fast for a proper union to occur. It is like trying to catch another car to merge with it while both of you are racing down a highway at top speed. The opportunity for growth is ripped away by the sheer velocity. Their pristine state offers us a unique window into the conditions of the early universe, a time when galaxies were built through rapid, chaotic collisions. They defy the standard evolutionary tracks we have written, forcing us to question if we have misunderstood the very life cycle of a galaxy. Are they the finished products of a forgotten era, or are they simply waiting, biding their time for a change we cannot yet foresee? These red nuggets are not the only ancient relics hiding a secret. When we peer into the dense swarms of stars known as globular clusters that orbit the Hercules galaxies, we find a different kind of missing object. Astronomers fully expected to find intermediate mass black holes there, the crucial missing link between the small black holes formed from collapsing stars and the supermassive giants at galactic centers. Yet the Hercules cluster appears to have none. This is not just a case of something being hard to find. It is a glaring and systematic absence where our theories insist something must be. The hunt for these middleweight black holes has turned up empty, and that void is shouting at us. So where did they all go? One possibility is that they are simply dark. An intermediate mass black hole that is not actively feeding, not pulling in gas and dust, gives off no telltale X-ray signature for our telescopes to catch. It would be a silent predator lurking in the core of a glittering star cluster, completely invisible to our current search methods. Another, more dramatic theory is that these black holes were violently ejected from their homes. The core of a globular cluster is a gravitational pinball machine. When black holes interact, their immense gravity can slingshot them out into the empty space between galaxies at incredible speeds. The Hercules cluster, with its dense environment and frequent galactic encounters, could be a perfect factory for producing these cosmic exiles, flinging its intermediate mass black holes into the eternal dark. But the most unsettling idea is that our methods of detection are fundamentally flawed for this specific, chaotic environment. The techniques we use to weigh a black hole by watching the dance of stars around it might fail in the crowded core of a globular cluster. The stellar orbits there are not clean, simple circles. They are a tangled web of gravitational influences from thousands of stars. The subtle signature of an intermediate mass black hole's gravity could be completely washed out by this noise, like trying to hear a single whisper in a roaring stadium. This missing link forces a profound question. Is the Hercules cluster truly unique, or is it showing us that the standard path of black hole growth from small to supermassive is a story we have written incorrectly? If these stepping stones do not exist where we most expect them, our entire understanding of how the universe builds its most mysterious objects may need to be rewritten. And if we are wrong about the black holes we cannot see, what does that say about the very nature of the darkness that surrounds them? These galactic rotation curves present a mystery that strikes at the very heart of physics. When astronomers measure how fast stars orbit the center of certain Hercules cluster galaxies, they find something deeply illogical. The stars on the outer edges are moving far too quickly. According to the established rules of gravity, the combined pull from all the galaxy's visible stars, gas, and dust is not nearly strong enough to hold these speeding stars in their tracks. They should be flung off into the void, yet they remain, clinging to impossible orbits. For decades, the solution seemed to be dark matter. The gravity from an immense, invisible halo of this mysterious substance was thought to provide the extra pull needed to explain the star's speed. But here in Hercules, that explanation is breaking down. For some of these galaxies, even when we add in the calculated pull from their dark matter halos, the math still does not add up. The stars are still moving too fast. It is as if you carefully weighed a car and then watched it accelerate as if it were weightless, defying every known law of motion. This anomaly forces us to consider radical alternatives. One compelling idea is that our understanding of gravity itself is wrong on galactic scales. A theory known as modified Newtonian dynamics, or MUND, proposes that gravity behaves differently when its pull becomes incredibly faint, like it is in the vast outer reaches of a galaxy. In this view, there is no missing dark matter, just a subtle change in the fundamental force that binds the universe. It is a controversial but powerful idea. Another possibility is that the missing mass is not dark matter at all, but ordinary matter hiding in plain sight in forms we have not yet learned to see. Could vast populations of cold, failed stars, rogue planets, or primordial black holes be woven throughout these galaxies, providing the extra gravitational glue? We are left with a fundamental choice. Do we invent a new, unseen substance to fill the gap in our equations, or do we rewrite the equations themselves? The spinning galaxies of Hercules are not just collections of stars. They are cosmic laboratories testing the laws of physics to their breaking point. The frantic spin of galaxies presents one dilemma, but the quiet spaces around them hide another. Orbiting the massive galaxies of the Hercules Cluster should be a swarm of smaller cosmic companions, countless dwarf galaxies that are predicted by our most advanced dark matter simulations. Yet when we count them, the numbers do not add up. We are faced with a stark discrepancy known as the missing satellites problem. Where our virtual models show a bustling celestial metropolis, our telescopes reveal a strangely quiet suburb. This is not a simple case of overlooking a few faint objects. It is a fundamental mismatch between prediction and observation. The simulations are incredibly detailed, tracing how the gravitational pull of dark matter should have clumped together in the early universe, seeding the formation of these small galaxies. They tell us we should be seeing hundreds, even thousands, of these faint dwarfs for every large galaxy like our Milky Way. In Hercules, we see only a handful. So where did they all go? One possibility is that our understanding of galaxy formation itself has a critical flaw. There might be a threshold, a minimum size or density that a clump of dark matter must have for stars to ever ignite within it. Perhaps the vast majority of these dark matter halos are simply too small or too diffuse to ever light up, leaving them as completely dark, invisible ghosts orbiting the larger galaxies. We would never see them, but their gravitational pull would still be there, a hidden population of shadows. Another, more radical idea is that the dark matter particle is different than we assume. If dark matter were slightly warmer or more energetic than the cold, slow-moving particle we usually imagine, it would not clump together as easily on small scales. This warm dark matter would naturally produce far fewer of the small, dense halos needed to birth dwarf galaxies, potentially solving the missing satellites problem at its root. Then there is the possibility of destruction. The Hercules Cluster is a violent environment. Could these fragile dwarf galaxies have been torn apart by the immense gravitational tides of their giant neighbors, their stars scattered into a faint, undetectable haze that now blends into the general glow of the cluster? We are left to wonder if the universe is more efficient at destroying these small structures than we ever anticipated, or if our cosmic maps are missing an entire class of invisible, failed galaxies. This quiet absence speaks volumes, forcing us to question whether the dark universe is built from the blueprint we think it is. Amidst the silent absence of dwarf galaxies, the Hercules Cluster unleashes a torrent of invisible bullets. Astronomers have detected intense, localized hotspots of cosmic rays, particles traveling at nearly the speed of light and carrying energies that dwarf anything produced in our most powerful particle colliders. These are not gentle streams, but violent, focused bombardments with no apparent source. We cannot see the cosmic gun that is firing them. The usual suspects, like the turbulent aftermath of a supernova explosion or the raging heart of an active galaxy, are nowhere to be found in these specific, concentrated zones. It is as if you were standing in a field being pelted by high-velocity raindrops, yet the sky above you is completely clear. So what cosmic accelerator is hidden from our view? One of the most tantalizing possibilities is that we are witnessing the final death cry of dark matter. According to some theories, when two dark matter particles collide, they could annihilate each other in a flash of energy, producing a shower of familiar particles, including these ultra-high-energy cosmic rays. These mysterious hotspots could be the signature of dense clumps of dark matter finally meeting their end, revealing their presence through their spectacular destruction. Another candidate is a population of primordial black holes. These would not be the black holes formed from dead stars, but hypothetical relics from the universe's first second, tiny and numerous. As they evaporate over eons through Hawking radiation, they could release tremendous bursts of energy, potentially creating these intense cosmic ray signatures. Or perhaps we are seeing the aftermath of collisions between exotic, unknown particles that we have not yet discovered, a fundamental physics process playing out on a cosmic scale. The energy involved is so immense that it points to forces and events beyond our standard model of particle physics. These silent, invisible hotspots are like messages from a hidden realm, etched into the most energetic particles in the universe. They challenge us to decipher a language written in pure energy, a language that may finally tell us what the majority of the cosmos is truly made of. These invisible cosmic rays point to forces beyond our sight, but there is a motion affecting entire galaxies that we can actually measure. Across the cosmos, galaxy clusters, including Hercules itself, are caught in a mysterious current. They are all drifting in the same specific direction, not as part of the universe's general expansion, but as if being pulled by some immense, unseen force. Astronomers call this the dark flow. It is a coordinated motion on a scale so vast it defies all conventional explanation. The gravitational pull from every known structure in our observable universe, from nearby superclusters to the most distant filaments of galaxies, has been meticulously calculated. None of it accounts for this relentless collective drift. It is as if every ship on the ocean was slowly, steadily being tugged by a hidden current, one that originates from beyond the horizon of the known world. The most controversial and thrilling hypothesis is that this flow is evidence of a gravitational pull from something entirely outside our universe. The immense gravity of a neighboring cosmos in a vast multiverse could be exerting a tidal force on our own, drawing these clusters toward a realm we can never directly see. Think of it as a cosmic magnet on the other side of an impenetrable wall, its influence felt but its source forever hidden. Another possibility reaches even further back in time, suggesting this flow is a fossil from the era before the Big Bang. A structure from a previous cosmic cycle, a remnant of a universe that existed before our own, could have imprinted this directionality onto the fabric of reality as our universe was born. Its gravitational echo would still be guiding galaxies today, a ghostly hand from a time before time. This is not just a minor anomaly in the data. The dark flow suggests that our universe is not an isolated island, but part of a much larger and stranger cosmic geography. If the Hercules Cluster and its neighbors are all moving in a way that nothing inside our reality can cause, then the very definition of what is inside and outside our universe begins to blur. We are left to wonder if we are merely one piece in an infinite cosmic puzzle, feeling the gravitational breath of another reality entirely. This coordinated drift of entire clusters is a humbling thought, but the very fabric of space within the cluster is behaving in ways that are just as strange. When we use the universe's own natural telescopes, a phenomenon called gravitational lensing, we expect to see a predictable distortion. A massive galaxy cluster like Hercules should bend the light from a more distant object, such as a quasar, creating multiple magnified images of it. And it does. The problem is that the brightness of these duplicate images is all wrong. According to the precise equations of general relativity, which have passed every test for over a century, the brightness of these mirrored quasars should follow a specific calculable pattern. In Hercules, they do not. Some images are far brighter than they should be, while others are curiously dim. It is as if you were looking at yourself in a funhouse mirror, and one reflection was glowing with light while the other was cloaked in shadow, a clear violation of the mirror's known properties. This anomaly suggests that something is warping space-time in a way that Einstein's theory does not account for. The smooth, predictable curvature of space around these massive galaxies might be textured or lumpy on scales we cannot directly see. Perhaps vast clouds of rogue planets or cold, dark stars are adding tiny, unseen kinks to the gravitational lens, focusing light in unexpected ways. Or maybe the dark matter itself is not smoothly distributed as we model it, but is instead clumped into invisible micro-halos that act like a swarm of smaller lenses, scrambling the light and creating these impossible brightness variations. The very rules of how light travels through the cosmos seem to be subtly broken here, and at the same time, from the same general depths of the cluster, we detect another class of enigma, repeating gamma-ray bursts. These are not the single, catastrophic blasts that mark the death of a massive star. These are precise, energetic eruptions that fire off again and again from the exact same point in the sky. Yet when we point our most powerful telescopes at that location, we see nothing. No galaxy, no star, no visible source of any kind. It is a cosmic gun that fires repeatedly, but we cannot find the shooter. What could possibly power such violent, repetitive explosions without leaving a trace? One of the most speculative but compelling ideas involves exotic structures in spacetime like wormholes. Theoretically, the mouth of a wormhole could act as a natural particle accelerator. If matter from one side falls through and collides with matter from our side, it could release a tremendous flash of gamma rays. The repeating nature of the bursts could be due to a regular stream of material, perhaps from an orbiting star or a disk of gas, periodically feeding this invisible engine. Alternatively, the source might be a magnetar, a type of neutron star with an unimaginably powerful magnetic field, but one that is so enshrouded in dust or so distant that its visible light is completely extinguished before it reaches us. The conjunction of these two mysteries, the flawed lenses and the ghostly repeaters, points to a profound possibility. We might be observing the fingerprints of physics beyond general relativity, where spacetime itself has a quantum graininess or can be permanently twisted by objects we have not yet dreamed of. The Hercules Cluster is not just challenging what we see, it is challenging the very stage upon which the cosmic drama plays out. If the rules of space and time are not constant here, what other fundamental truths might be waiting to be unraveled? Floating between the brilliant galaxies are immense, silent clouds of pure hydrogen gas. These are not the familiar glowing nebulae where stars are born, but vast, dark reservoirs of primordial fuel adrift in the emptiness. They are the ghosts of gas, structures so large they dwarf entire galaxies, yet they contain not a single star to light their way. Their existence is a double mystery. How did such colossal, isolated clouds form, and why have they remained dormant, refusing to collapse under their own gravity and ignite into new suns? One theory suggests they are the pristine building blocks of the universe, left over from the earliest times. According to our models of cosmic evolution, vast filaments of hydrogen should have woven the cosmic web, with galaxies forming at the densest knots. These clouds could be surviving strands of that ancient web, pockets of gas that somehow avoided the frantic star-forming rush that consumed the rest of the early universe. They are frozen in time, preserving the composition of the cosmos just moments after the Big Bang. Yet their survival in the violent environment of the Hercules Cluster is a puzzle in itself. The gravitational tides from passing galaxies should have ripped them apart or triggered their collapse eons ago. Another, more dramatic possibility is that they are the scattered debris from a catastrophic galactic collision. When two galaxies merge in a slow, cosmic dance, they can fling immense streams of gas out into intergalactic space, like water droplets shaking from a dog's coat. These clouds could be the orphaned remnants of such a violent encounter, left to drift alone and cold, but this still does not fully explain their failure to form stars. Star formation requires a trigger, a compression of the gas, often from a shock wave or a collision with another cloud. In the profound quiet between galaxies, these triggers may be absent. The gas could be too hot, its atoms too energetic to clump together, or perhaps it lacks the tiny, microscopic dust grains that normally act as seeds for collapse. Without these catalysts, the clouds remain in a perpetual state of suspense, holding the potential for entire galaxies within them, yet never taking that final step. Are they the future sites of new galactic empires, or are they cosmic fossils, destined to slowly evaporate or be consumed by their brighter neighbors? Their silent presence forces us to question if we are witnessing the beginning of a story or the quiet, forgotten end. The silent hydrogen clouds are not the only ancient ghosts haunting this region of space. The Hercules Cluster appears to be aligned with one of the most profound mysteries in all of cosmology, a colossal cold spot in the cosmic microwave background. This is the faint afterglow of the Big Bang, the oldest light in the universe, and it should be almost perfectly uniform. Yet here it holds a blemish, a vast and inexplicably cold region that seems to correspond with the cluster's location. This is not a small imperfection, it is a cosmic chill so large and so statistically unlikely that it defies simple explanation. It is as if you found a frozen continent on a map of the world where the climate should be uniformly temperate. So what could cast such a long, cold shadow across the dawn of time? One radical idea is that we are seeing the imprint of a cosmic texture. This is a theoretical defect in the fabric of spacetime itself, a knot that formed as the universe cooled and expanded in its first moments. If such a texture existed and then unwound, it would release an immense amount of energy, creating a gravitational well that would leave a cold spot on the cosmic microwave background. The Hercules Cluster, sitting in that same patch of sky, might be nestled within this permanent scar on reality, a place where the very vacuum of space has a different energy. An even more staggering possibility is that the cold spot is a bruise from a collision with another universe. In the multiverse scenario, our cosmos could have bumped into a neighboring one in the distant past. That colossal impact would have drained energy from our universe in that specific location, leaving behind a cold imprint that has lasted for over 13 billion years. The Hercules Cluster, then, would be situated at ground zero of a cataclysm that redefined the boundaries of existence. A third, more conservative but still puzzling theory suggests the cold spot is not a primordial feature at all, but a trick of the light. It could be caused by a vast supervoid, an enormous region of relatively empty space between us and the cosmic microwave background. As light travels through such a void, it loses energy, an effect similar to how a sound wave deepens in pitch as it moves away. This could create the illusion of a cold spot. The problem is, to create a chill this significant, the void would need to be unimaginably vast, far larger than any structure we believe possible in our universe. Its sheer size would break our current models of cosmic evolution. The correlation with the Hercules Cluster adds another layer of intrigue. Is the cluster itself part of this supervoid structure, or is it merely a foreground object that happens to lie in the same direction? We are left with a fundamental choice between explanations that are each, in their own way, extraordinary. Is the cold spot a relic of a flawed vacuum, the scar of a multiverse collision, or the shadow of an impossible emptiness? This single anomaly connects the very largest scales of the cosmos to the specific location of the Hercules Cluster, suggesting that its mysteries are not local, but are woven into the deepest history of everything. This cosmic chill from the dawn of time is not the only anomaly that seems to cluster here. When astronomers map the universe by measuring galactic redshifts, they expect to see a smooth, continuous distribution. Redshift is the key to cosmic cartography, the stretching of light from distant galaxies as the universe expands, which tells us how far away they are and, by extension, how far back in time we are looking. Yet in the direction of the Hercules Cluster, this timeline has a puzzling gap. A specific slice of cosmic history appears nearly empty, a so-called redshift desert where our telescopes find only a sparse scattering of galaxies in a volume of space that should be teeming with them. It is as if you were reading a history book and discovered that an entire century was missing, with only a few scattered paragraphs where there should be entire chapters of development. The presence of galaxies within this desert is profoundly disruptive. If our redshift measurements are correct, it means that during this specific era, the rate of galaxy formation and evolution must have slowed to a crawl for some unknown reason, creating a cosmic pause button that our models of a steadily evolving universe do not account for. What could cause such a widespread stalling of cosmic construction? Perhaps a vast, uniform energy field temporarily suppressed the collapse of gas clouds, putting a freeze-on star birth across an immense region. Or maybe a wave of early supernova cleared out the primordial gas so efficiently that it took eons for it to cool and collapse again, creating a billion-year lull in galactic activity. But there is a more unsettling possibility. What if the desert is an illusion and the problem lies not with the galaxies themselves, but with our fundamental method of measuring cosmic distances? Redshift is the cornerstone of modern cosmology, the ruler we use to measure the expanding universe. If these galaxies have redshifts that place them in the desert, but they actually belong to a different time, it would mean our ruler is warped. Their anomalous placement could be a clue that our understanding of dark energy's influence on the universe's expansion is incomplete, or that unknown physical processes within the galaxies themselves are subtly altering their light, tricking our instruments. These lonely galaxies in the redshift desert are therefore more than just missing inhabitants. They are potential whistleblowers, their very existence challenging either the story of how galaxies grow or the very tools we use to write that story. Do we trust the map, or is the universe telling us we have been reading it wrong all along? Out of the silent depths of the Hercules Cluster, a signal screams. It is a fast radio burst, a pulse of radio waves so intense it outshines an entire galaxy for a few fleeting milliseconds. This is not just a single catastrophic blast, but a repeating one, firing off again and again from the same precise location. The signal itself holds a crucial clue, a fingerprint known as its dispersion measure. As the burst travels across millions of light-years, it plows through clouds of electrons, which slow down the lower frequency parts of the signal more than the higher frequencies. The staggering delay we measure in this repeating burst tells us it has passed through an extraordinary amount of material, a path far denser and more complex than any simple journey through intergalactic space should be. It is as if the signal has been forced to wade through an invisible cosmic swamp, fighting its way through a fog we cannot see. So what could possibly generate such a powerful, repetitive signal from within a nest of galaxies? And what is creating this impossibly dense barrier along its path? One of the leading suspects is a magnetar, a type of neutron star with a magnetic field so powerful it could strip the information from a credit card from a distance of 100,000 miles. The crust of such a star can crack under the strain, releasing titanic starquakes that might power these brilliant flashes. Yet, even the most violent magnetar struggles to explain the sheer energy and, more importantly, the bizarre dispersion of this particular signal. The path seems choked with matter, but when we look, we see nothing but ordinary space. This has led to more exotic proposals. Could the burst be the result of something interacting with dark matter itself? Perhaps the signal is passing through a dense, invisible clump of dark matter, a halo so concentrated that its subtle influence on particles is dramatically slowing the radio waves, creating that unusual dispersion measure. Another, far more speculative idea is that we are witnessing an artifact of technology. While it is a concept we must approach with immense caution, the repetitive nature and structured energy output are patterns that, in our own limited experience, we associate with engineered systems. It is the least likely explanation, but it forces us to confront a profound question. If we were to ever discover a signal that was clearly artificial, how would we even begin to understand its purpose or its origin? This repeating burst is more than a cosmic curiosity. It is a message in a bottle washed up on the shore of our understanding, and we are only just beginning to learn the language in which it is written. This erratic heartbeat of a quasar presents a riddle of cosmic proportions. One moment it is a brilliant beacon, a raging furnace of light and radio waves powered by a supermassive black hole feasting on a stupendous amount of matter. The next, its radio voice falls completely silent, as if a switch has been thrown deep within its core. This is not a gradual dimming, but an abrupt, total shutdown that defies the typically steady glow of these cosmic engines. How can an object capable of outshining entire galaxies simply turn off its most powerful signature without warning? One compelling explanation involves a cosmic wobble. The black hole's powerful jets, which generate the intense radio emissions, might be processing. Imagine a spinning top that slowly wobbles as it rotates. If the jets are on such a tilted axis, they could periodically swing away from our line of sight, pointing their incredible energy into the void of space where our telescopes cannot detect it. For a time, the quasar would appear radio quiet to us, even though its engine continues to roar at full power. Another possibility is a recurring celestial eclipse. Vast, thick clouds of dust and gas, perhaps from a recently consumed star or an unstable region of the accretion disk, could be drifting directly into our view. These clouds would act like a dense cosmic fog bank, completely blocking the radio waves from the central engine and plunging our observations into temporary silence. The most intriguing theory, however, involves a dance of titans. At the heart of this galaxy might not be one, but two supermassive black holes locked in a tight orbital embrace. As they whirl around each other in a binary system, their immense gravitational forces would violently churn the surrounding accretion disk of gas. Their chaotic dance could periodically disrupt the flow of fuel onto one or both black holes, or their gravity could fling the inner disk of material completely outward, creating a temporary fuel shortage that starves the radio jet and causes it to sputter out. This would be a self-inflicted silence, a cycle of feasting and famine dictated by the orbital rhythm of two cosmic monsters. This on and off behavior forces us to question the very stability of these brilliant beacons. Are they not the steady lighthouses we once thought, but instead flickering torches in a chaotic wind? The quiet periods are not an absence of power, but a message about the turbulent, dynamic environment swirling around the most violent objects in the universe. This age paradox strikes at the very timeline of the cosmos itself. Among the ancient stars of the Hercules Cluster, its globular clusters present a chronological impossibility. These dense, spherical swarms of stars are the universe's senior citizens, and by measuring their composition and the cooling of their oldest stars, we can estimate their age. The results are deeply unsettling. Some models place these clusters as being older than the calculated age of the universe. It is a finding as illogical as discovering a grandfather who is older than the country he was born in. How can something exist before the universe itself began? The most straightforward answer points to a flaw in our stellar clocks. Our methods for dating stars rely on complex models of how they burn their nuclear fuel and evolve. If our understanding of the inner workings of stars is even slightly incorrect, for instance, if the rate of certain nuclear reactions is different in these pristine, ancient environments, our age estimates could be wildly off. It is like using a faulty hourglass to time a race. The reading you get is precise but completely wrong. A more radical solution challenges the very constancy of physics. What if the fundamental constants of nature, like the strength of gravity or the speed of light, are not truly constant? Some theories suggest they may have been slightly different in the intensely hot, dense early universe. If the force of gravity was weaker long ago, the first stars would have burned their fuel more slowly, living far longer than our current models predict. This would mean the stars in these globular clusters only appear to be impossibly ancient because we are measuring them with the wrong ruler, a ruler that has changed over billions of years. Then there is the most profound possibility of all, that these clusters are not from our universe's first generation, but are literal relics from a previous cosmic cycle. The concept of a cyclical universe where a big bang is followed by a big crunch and then another bang in an endless cycle offers a staggering explanation. The globular clusters of Hercules could be the sole survivors, the only structures robust enough to make it through the end of one universe and into the beginning of our own. They would be cosmic immigrants carrying the history of a reality that existed before our own. This paradox forces us to confront the reliability of our most basic cosmic measurements. Are we misreading the stars, or are we misreading the very history of existence? These glittering star clusters are not just beautiful objects, they are temporal anomalies holding a secret about time that we are only beginning to decipher. Even the most brilliant galaxies account for only a fraction of the universe's normal matter. When astronomers tally all the visible stars, gas, and dust in the Hercules cluster, they come up dramatically short. A significant portion of the cluster's ordinary matter, the stuff you and I and every visible thing is made of, is simply missing. This is the baffling case of the missing baryons. Baryons are the familiar protons and neutrons that form atoms, the building blocks of the material world. Based on our most precise measurements of the early universe, we know exactly how much of this baryonic matter should exist today. Yet in a mature structure like the Hercules cluster, we can only locate about half of it. It is a cosmic heist on an unimaginable scale, where the thief has left no fingerprints and the loot is seemingly invisible. The prime suspect in this mystery is a theorized web of faint, superheated gas known as the warm-hot intergalactic medium, or WIM. Picture the space between galaxies not as a perfect vacuum, but as a steamy, diffuse fog of million-degree hydrogen. This gas is so tenuous and so hot that it does not glow in visible light, remaining virtually transparent to our telescopes. We have tried to hunt for it by looking for its subtle fingerprints. As light from distant quasars passes through this invisible fog, the WIM should absorb specific wavelengths of ultraviolet and X-ray light, leaving tiny, telltale dips in the spectrum. We have searched for these absorption lines, and while we have found hints, the total amount of gas they account for is nowhere near enough to solve the missing baryon problem. Another method involves looking for the WIM's own faint emission in X-rays, but the signal is incredibly weak, easily drowned out by the brilliant glow of other sources. It is like trying to hear a whisper in a roaring concert hall. So why is this ordinary matter so elusive? One possibility is that our detection methods are simply not sensitive enough yet. The WIM might be even more diffuse and patchy than we thought, its signal scattered and faint beyond the reach of our current technology. But a more intriguing idea is that the missing baryons are not in the form we expect at all. Perhaps they have collapsed into an unknown state, forming vast, dark structures we cannot conceive of. Could there be a population of cold, starless gas clouds, so dark and cold they emit no detectable radiation? Or maybe the intense gravitational fields of the cluster have compressed the gas into strange, ultra-dense filaments that our observations simply cannot resolve. The very nature of ordinary matter, the stuff we thought we understood best, is now in question. Where has half the visible universe gone, and what form is it hiding in? The universe's oldest stars hold a chemical memory of their birth, a pristine record of the elements forged in the fiery dawn of time. Yet when we read that record in the ancient suns of the Hercules Cluster, we find a page has been torn out. The element lithium is missing. According to our most precise models of Big Bang nucleosynthesis, the frantic nuclear cooking that occurred in the first few minutes of the cosmos, a specific amount of lithium should have been created. This lithium should be present in the atmospheres of the most ancient stars, which formed from that pure, early material, but it is not there. The measured abundance is only about a third of what our theories insist we should find. This is not a minor accounting error, it is a fundamental mismatch between the universe's recipe and the final product we actually observe. So what happened to the lithium? One line of investigation points the finger at the stars themselves. Over billions of years, a star's internal processes might slowly drag lithium down from its visible atmosphere into the hotter interior, where it is destroyed in nuclear reactions. It is as if the star is gradually burning the evidence of its own origin. While this is a plausible mechanism, the efficiency required to account for such a uniform and significant deficiency across so many different stars is staggering. It demands that these vastly different stellar environments all process lithium in exactly the same way, a coordinated destruction that seems almost too perfect. This has led physicists to a more radical conclusion. Perhaps the error is not in the stars, but in our understanding of the Big Bang itself. The models of nucleosynthesis are built upon a foundation of known nuclear reaction rates and the conditions of the early universe. What if a previously unknown particle, like a certain type of dark matter, was present in those first moments? Such a particle could have altered the delicate balance of proton and neutron interactions, effectively shutting down the production line for lithium before it could create the expected amount. Or the laws of physics themselves might have been slightly different under those extreme conditions of temperature and density. A subtle change in the strength of the fundamental forces could have skewed the entire nuclear chain reaction, leaving us with the lithium deficit we see today. This missing element is a quiet but persistent ghost. It whispers that our story of the universe's first moments, a story we tell with great confidence, may be missing a crucial chapter, one written in the faint spectral lines of the oldest stars in the cosmos. Winding through the heart of the cluster like a forgotten river of light is a structure that should not exist. Astronomers call it the Hercules Stream, a vast, coherent flow of stars moving in unison, a ghostly bridge connecting points of nothingness. This is not the shredded tail of a galaxy we can still see, a predictable result of a slow-motion collision. This stream is an orphan, a river without a source, its stars all sharing a common velocity and composition yet belonging to no visible parent galaxy. It drifts through the crowded core as a celestial mystery, a single question written in a billion suns. How did such a perfectly structured flow of stars come to be, and what erased its origin from the sky? One of the most compelling theories is one of total destruction. The stream could be all that remains of a dwarf galaxy that ventured too close to the cluster's immense gravitational heart. Over eons, the tidal forces, the difference in gravity between the galaxy's near and far side, would have pulled it apart like cosmic taffy. First, its outer stars would have been stripped away, and then its very core would have been unraveled until all that was left was this long, thin stream of stars, a smear on the windshield of the cluster. The process would have been so complete, so violent, that the galaxy's central core was utterly dispersed, leaving no visible remnant behind. but another possibility involves a near miss of epic proportions. Perhaps two large galaxies passed by each other at tremendous speed, not colliding head-on but swinging past in a gravitational slingshot maneuver. Their mutual gravity could have reached out into intergalactic space and plucked a billion stars from their orbits, drawing them out into this long, flowing ribbon that now follows the path of that ancient encounter. The original galaxies, having exchanged this stellar material, would have continued on their way, their structures largely intact, leaving this silent witness to their brief, dramatic dance. The most profound explanation, however, is that the Hercules stream is a primordial relic. It might be a fossil from the cluster's own formation, a thread of stars that never fully collapsed into a proper galaxy. In the early chaos, as dark matter wove the cosmic web, this strand of gas and stars might have been left behind, frozen in its infancy, and has simply drifted through the cluster ever since, a living fossil from a time when the universe was building its largest structures. This stream forces us to confront the sheer violence and subtlety of galactic evolution. It is evidence of a destruction so absolute it leaves only a whisper, or a construction so delicate it was never finished. As we trace its path across the void, we are left to wonder how many other such ghosts are flowing through the cosmos, the only remains of stories that ended before our time began. The silent flow of the Hercules stream is a testament to cosmic destruction, but some disappearances in the cluster are far more abrupt. There is a class of objects that simply blink out of existence, vanishing from one observation to the next without any trace. These are not faint galaxies slipping below our detection threshold. These are bright, confirmed sources of light that are present in one astronomical survey and utterly gone in the next. A celestial lighthouse has been switched off, leaving us staring at an empty patch of sky. The most plausible explanation is as violent as it is invisible, a phenomenon known as a failed supernova. In a typical massive star's death, its core collapses into a dense neutron star, triggering a shock wave that blasts the star's outer layers into space in a brilliant supernova explosion. But in a failed supernova, a truly colossal star might skip the firework display entirely. Its core collapses directly into a black hole, and instead of exploding outward, the star's entire bulk simply falls inward, disappearing from the visible universe in a matter of moments. It is a stellar death so complete it leaves no memorial, just a silent black hole where a sun once shone. Another possibility involves a cosmic cloak of unprecedented scale. Perhaps these vanishing galaxies are not dying but are being hidden. A thick, swirling wall of cosmic dust and gas, possibly from a recent galactic collision, could have drifted directly into our line of sight. This would not be a simple haze, but an impossibly dense and vast shroud, blocking all wavelengths of light from the galaxy behind it, from optical to infrared. The galaxy would still be there, shining brightly, but to our telescopes, it would have effectively vanished behind an impenetrable curtain. Yet, the sheer scale and suddenness of some of these disappearances push us toward more speculative frontiers. Could we be seeing the fingerprints of a reality with more dimensions than the three of space and one of time we experience? Theoretical physics allows for the possibility of higher spatial dimensions, curled up or hidden from our perception. A catastrophic interaction with a structure in such a dimension, a brain as they are called, could theoretically cause a localized gravitational collapse so severe that it effectively removes the object from our dimensional plane. It would be less like an explosion and more like a puncture, a leak from our universe into another. While this remains a highly speculative idea, it underscores the profound nature of the mystery. We are left with a fundamental question. Are we watching stars die in the quietest way possible? Are we witnessing the ultimate cosmic illusion? Or are we getting glimpses of a cosmic anatomy far stranger than we ever conceived? When an entire galaxy can simply cease to be, it forces us to reconsider the very permanence of the cosmos. A strange synchronicity echoes through the cluster, a rhythm in the stellar depths. The supernovae here are not scattered randomly like isolated firecrackers. Instead, they appear to flash in distinct patterns, both in their locations and in their timing, as if an invisible wave of destruction is sweeping through the galactic neighborhood. This correlated distribution defies the laws of chance, suggesting that these cataclysmic explosions are somehow talking to each other, or more accurately, that something is triggering them in a coordinated sequence. The most logical explanation points to a domino effect of star formation. Galaxies in the cluster do not exist in isolation, they brush past each other, their gravitational embraces stirring up vast reservoirs of cold gas. These interactions can trigger immense waves of new star formation, birthing entire generations of massive, short-lived stars. These stars burn bright and die young, and if a wave of star birth sweeps through a group of galaxies, a wave of supernova deaths will inevitably follow a few million years later. It is a cosmic echo where the gravitational nudge of one galaxy sets a timer for stellar explosions in another, but there is a more exotic and unsettling possibility. What if the supernova themselves are the trigger? The shock wave from a single supernova explosion is a titanic thing, capable of compressing nearby gas clouds and igniting the birth of new stars. In the dense, crowded environment of the Hercules Cluster, could the blast wave from one supernova travel across intergalactic space? Could it slam into a gas-rich region in a neighboring galaxy, compressing the gas and triggering not just star formation, but the specific formation of the kinds of massive stars that are destined to explode? This would create a true chain reaction of stellar death, a self-propagating wave where each explosion plants the seeds for the next, a feedback loop of cosmic violence. The implications are profound. If such a mechanism is real, it would mean that the life and death of stars is not always a local affair. A stellar explosion in one galaxy could directly influence the evolutionary fate of another, weaving the galaxies of the cluster together in an intricate dance of creation and destruction that we are only just beginning to perceive. Are we watching a simple celestial coincidence, or the first evidence of a universe where death begets death on an intergalactic scale? This ancient cluster, seemingly older than time, confronts us with a timeline that feels broken. Yet another temporal paradox emerges when we peer back to the universe's infancy, to a gathering of infant galaxies known as a protocluster. This cosmic nursery, a construction site for what will one day become a massive cluster like Hercules, is already far too heavy for its age. According to our established blueprint of cosmic growth, known as hierarchical structure formation, the universe builds from the bottom up. Small structures like dwarf galaxies should merge slowly over billions of years to form the giant clusters we see today. But this protocluster defies that rulebook. It possesses a staggering amount of mass, as if the entire skyscraper was assembled overnight rather than being built brick by brick. How could so much material come together so quickly, so early in cosmic history? This discovery points toward a radically different assembly process, a top-down formation where vast sheets of gas and dark matter collapsed all at once to create these colossal structures in a single, rapid event. Imagine watching a city materialize fully formed from a whirlwind, bypassing the slow, painstaking work of laying each foundation and raising every wall. This is the scale of the anomaly we are witnessing. The implications shake the foundations of cosmology. If this top-down model is correct, our entire understanding of how the universe organized itself after the Big Bang is incomplete. The gentle, bottom-up gravitational dance we have long envisioned might have been punctuated by episodes of violent, rapid collapse where gigantic swaths of the cosmic web fell in on themselves all at once. What force could have triggered such an immediate and coordinated collapse? Was the density of matter in these regions so unimaginably high that gravity's pull became irresistible from the very beginning? Or does this point to a flaw in our understanding of dark matter's behavior in the primordial universe, suggesting it clumped together with an efficiency we never predicted? This too-massive protocluster is a fossil from an era of more extreme and faster-paced construction, forcing us to rewrite the story of how the cosmos built its greatest cities. Carved within the searing, X-ray glow of the cluster's hottest gas are two immense voids, colossal bubbles of nothingness that defy their own creation. These anomalous X-ray cavities are perfect, symmetrical spheres, each one a ghostly imprint of a power that has long since vanished. They were blown like cosmic glassblowers' orbs by the jets of a supermassive black hole at the cluster's heart. Yet the very jets that should be filling these cavities with raging energy are now quiet, or far too feeble to account for the sheer scale of these structures. It is as if you discovered two perfectly spherical craters on the moon, each 1 mile wide, but found no evidence of the impacting meteors that must have caused them. The energy required to excavate these voids from the multimillion-degree gas is staggering, a single cataclysmic eruption that must have shaken the entire cluster. But when we look at the black hole today, its activity is a mere whisper compared to the roar we know it must have unleashed. This presents a haunting possibility. These cavities are not being actively formed, but are relics of a past fury. They are the fossilized echoes of an eruption that occurred millions of years ago, a brief, violent tantrum from the central black hole that has since subsided into an uneasy quiet. The pristine symmetry of the bubbles adds another layer of mystery. For them to be so perfectly balanced on either side of the galaxy, the jets that carved them must have been incredibly stable, firing with unwavering precision for eons. But black hole jets are known to wobble and precess like a spinning top slowly winding down. How could they have remained so perfectly aligned for so long? This suggests an even more exotic history. Perhaps the jets are not relics, but are still active in a way we cannot perceive, processing on a timescale so vast that we are merely seeing a single, frozen moment in their multi-million-year sweep. We could be looking at a snapshot of a slow-motion explosion, a single frame in a movie that lasts longer than human history. The existence of these silent, empty bubbles forces a profound question about the life cycle of these cosmic monsters. Do they sleep in cycles, waking for a brief, catastrophic feast that reshapes their entire surroundings before falling dormant again? And if so, what alarm clock is powerful enough to stir them from their slumber? We are left staring at the ghost of an explosion, a memory written in empty space, waiting for the next act to begin. Even the ghostly echoes of ancient explosions cannot fully explain the final, most pervasive mystery of this cluster. Washing across its entire expanse is a faint, uniform radio whisper known as the Hercules haze. This is not a brilliant beacon from a single galaxy or a sharp jet from a black hole. It is a soft, all-pervasive glow, a cosmic static with no clear point of origin, as if the very void between the galaxies is humming a quiet, energetic tune. Pinpointing its source is like trying to find a single raindrop in a dense fog. The light comes from everywhere and nowhere at once. So what could possibly produce such a widespread, uniform radio signal? One of the leading theories points to a celestial chorus of countless faint voices. The haze could be the combined radio murmur from a vast, unseen population of stellar remnants. Imagine millions upon millions of pulsars, the spinning cores of dead stars, and the expanding shells of ancient supernova remnants, each one too faint to be detected individually. Together, their collective radio whisper could blend into this diffuse, all-encompassing haze, a background hum of stellar death and decay that has been ongoing for billions of years. It would be the fossilized sound of the cluster's violent history preserved in radio waves, but there is another, far more tantalizing possibility. This haze could be the long-sought signature of dark matter itself. According to some theoretical models, when dark matter particles collide and annihilate one another, they could produce a cascade of familiar particles, including electrons. These electrons, spiraling at near light speed through the cluster's magnetic fields, would give off a specific type of radio emission known as synchrotron radiation. This would create precisely the kind of smooth, diffuse glow we see as the Hercules haze. If this is true, then we are not just looking at empty space, we are staring at a map of the dark matter particle itself, watching it slowly annihilate and reveal its presence in the only way it can. The Hercules haze, therefore, is more than just a final unexplained phenomenon. It is a potential window into the invisible 85% of the universe's matter. It represents the culmination of all the other mysteries, from the ghostly galaxies and the missing matter to the impossible black holes and the cosmic drift. Every strange occurrence in this cluster is a piece of a puzzle, and the haze could be the background upon which that entire puzzle is laid out. We have journeyed through 25 profound enigmas, each one a crack in the foundation of our understanding. They are not failures of our science, but invitations to look deeper, to think grander, and to remember that the greatest discoveries often begin not with an answer, but with a humble, thrilling question mark hanging in the dark. 25 profound mysteries, from the impossible power of Hercules to the ghostly whisper of the Hercules haze, all point to a single, humbling reality. This distant cluster is not merely a collection of galaxies, it is a cosmic courtroom where our most cherished theories are put on trial. The standard model of cosmology, our understanding of gravity, and even the life cycle of stars and black holes are all challenged by the evidence gathered here. Each anomaly is a crack in the foundation, a signpost pointing toward a deeper, more complex truth we have yet to grasp. These are not failures of science, but its ultimate purpose, invitations to venture beyond the map into the vast, uncharted territory of the unknown. The next great leap in understanding the universe may not come from staring at a textbook, but from looking up at the night sky with a renewed sense of wonder. Remember that the darkness between the stars is not empty, it is filled with questions waiting for their answers. If these cosmic enigmas captivated you, subscribe to continue this journey into the heart of the universe's greatest puzzles. And tell us in the comments what space mystery keeps you looking up at the stars.